Hi there, this is Om. So our final year project is about RAG system for research papers. So as the name suggests, we are creating a chatbot for RAG system for research papers using the concept of RAG. So what is RAG? RAG is basically a retrieval-augmented generation, where what happens that we encode the research paper's text using using vectors, and then we say, do similarity search on the user's query and send them for to LLMs to give a complete response. So what does RAG help us? So RAG helps us to give more context to the user's query, because normally the context is absent. So we first got the research papers with three main sources: ArcXIV API, Semantic Scholar, and Springer Nature. And as you can see, there were total 80,000 papers that we fetched using our system, and then using web scraping, and then we have trained, for now we have trained 900 research papers. Out of that, there are these many total embedding chunks and those many embedding vectors. So we, as you can see, the vectors are being loaded in FAISS. We are using Streamlit as backend for Stream as front end and backend, and also we are using the BGI for as the, you can say, embedder, which is open source on Hugging Face, So let us see. So what happens? The vector store has been initialized, the FAISS index and the Postgres database where the vectors are stored. We have used PG vector to store the database. So we can see here. Let's ask some query. What is NLP? So see, it first retrieves the required chunk. We are using FAISS here. So it sees the cosine similarity search and fetches the chunk. And currently, the API call has been given with the required context to Gemini. See, we can see BGAII again. So we are using this model for embedding BGAIEN. See, so the query has gone to Gemini and the response is here. Machine translation. You can see we have rendered the text perfectly as a markdown format. So this is basically a final year project. See. So here the relevant chunks are fetched again. Our architecture is this, as you can see. We have got document ingestion using web scraping, and then our RAG works like this, as document ingestion phase, where we take the PDF document splitter and we give it to embedding model, which was our BGAIEN. Then we go to query processing stage, where a query is converted into embeddings and stored in the vector database. Vector database is basically FAISS, and we store the vectors in Postgres PG vector using PG vector. Then when the user gives a query, we do similarity search, cosine similarity specifically, and then the context is gotten and context is sent to LLM to give to the user. So let's see. I think it has. The answer has come. Introduction to code tokenization. Code tokenization special. You can see here these are the research papers from which it took the relevant context. We have kept the k equal to 4 for now. We can increase that also. What is tokenization? Let's see where's code. See, you can see the code snippets here. Key takeaways. So this is our final year project.